Yeah, I'd like to introduce our first speakers, Kieran and Fiachna, who are going to talk about real experiences doing weekly sports broadcasts on 5G. Guys, take it away.
My name is Kieran Kunhya, and I'll be joined by Fiachna Murchu from Nemeton TV, and we're going to be talking about experiences from weekly sport broadcasts over 5G, what's possible and what isn't yet. Oh, next slide, please. It's not on my screen. So who are we at Open Broadcast Systems? A classic standard slide. We're a company specializing in software-based encoders and decoders from sport, news, and channel contribution, business to business. We're based in central London, so that's where I am right now. Big Ben is just to my left. You can just see the top of it, and various other famous places. It's worth saying, I think I mentioned we build everything in-house, hardware, firmware, software, you name it. And most importantly, not to be confused with open broadcaster software. One thing I'm doing a little bit unusually in this presentation is actually using 5G to give the presentation. I've actually done it before, but I thought it would be a good idea. So, I mean, if there is a problem, I will just replug the fiber back in. But at the moment, we have two 5G networks where I am, and so I'm using one of them at the moment to give this presentation. Hence why it's not hosted on my screen. Next slide.
Thanks, Kieran. So my name is Fiachna Murchu, Systems Manager with Nemeton. Who are Nemeton? We are Ireland's largest independent production company, and we specialize in live sport OBs. Our HQ is based in the south of Ireland, between Cork and Waterford City. And we also have an office in Glasgow in Scotland. Our main clients are Irish language broadcaster TG Ceathair in Ireland and Scots Gaelic broadcaster BBC Alba in Scotland. And we have our own fleet of 4 SNG trucks, KU band SAT trucks, and our own small 5 antenna teleport.
So let's talk about where we are today with 4G. As many of you know, over the last 10 years, there's been a massive growth of cellular bonding solutions, often in a backpack form factor. Very commonly used now in news gathering, broadly speaking, for things like talking heads, reporters in the field. In recent years, there's been increased use in sport. Probably fair to say, mainly around the web. There's relatively limited use for traditional high-end sports outside broadcasts. I'll come on to that in a minute. This is, of course, generally a single vendor walled garden solution, sort of Apple iPhone style. And in particular, these are quite different to traditional broadcasts in that they're adaptive bit rates. So the picture quality changes quite rapidly and often very aggressive adaptive bit rates. So even the slightest hint of network congestion, correct or otherwise, you see very aggressive changes in picture quality. And as I kind of talk about later, the big challenge with one of those algorithms is how do you actually decide everything's now okay? So as I kind of alluded to, probably fair to say not quite comparable to satellite or fiber for high-end productions. Things like adaptive bit rate and adaptive picture quality changes are fine if it's 5 minutes of a news reporter, but watching it for 2 or 3 hours on end with the picture quality changing all the time for something like sports, pretty jarring. That said, to play devil's advocate, do the end viewers actually notice? So people on this call probably will notice. I notice. I can pick out on a news broadcast which ones are done via satellite and fiber and which ones are done using cellular bonding quite easily. But does the end user actually notice these days? Probably not. Next slide. So why is 5G different? We've already got 4G, doing quite a lot with it. So what can we do with 5G? On paper, there's some massive improvements in performance. So 10 to 100 times increase in bandwidth compared to 4G. That's, of course, comparable or better than fiber connections. And Fiachna will talk a lot about that. 10 times decrease in ping time. So 4G, broadly speaking, is 30 to 50 milliseconds. 5G, in principle, going to get to single digits. Comparable to fiber as well. And Fiachna will talk more about this at a technical level with real-world data and measurements of jitter, etc. What's also really important is 5G has a massive investment push from the telco industry that broadcast can benefit from. And we've seen in other areas of broadcast, such as high-speed networking, 100 gigabit, 200 gigabit networking, or things like 3D graphics, AR, VR that come from the gaming industry, that the broadcast industry can ride on the coattails of much larger investments in technology. There's very fierce competition in many countries, very fast rollout of 5G. It's pretty fair to say that the telecom operators are build it and they will come like 4G. They didn't really know about things like the growth of social media, Instagram, Snapchat, Facebook when they built 4G, but they built it and people came, and we do that all the time. But they haven't quite figured out what the next big thing is for 5G. So they're going to build it and hope for the best. And there are also very large numbers of cell towers now with very, very fast 5G performance. It's actually in my home, we use 5G as the main internet source. It's faster than any other wired connection, which is interesting. And I guess the idealized unicorn is fiber performance anywhere. And Fiachna will talk about whether this is actually doable or not. Next
Thanks,
slide.
Kieran. So, an introduction to 5G. What is it? Many of you will know it is the 5th generation of mobile cellular communication technology. 5G, we hear a lot about it. It's also known as new radio. So a lot of places you will see 5G NR or NR only on its own in some technical documents. Why 5G for us? Well, we cover many venues in Ireland. A lot of them are visited only once per year, and for that we have satellite as our main contribution method for the last 20 plus years. So multi-annual fiber commitments in these venues are not cost effective. So 5G in theory will give us satellite flexibility while hopefully reducing the costs. 5G comes in 3 major forms as we see it. There is 5G NSA, or non-standalone. This is what we're seeing live on all networks in Ireland at the moment. 5G standalone then, this is under development, and we've been told approximately early 2023 we should start seeing this in some form. And then there's another little nuance to 5G, which is DSS, or dynamically shared spectrum. So this is the radio at the 5G tower will share the spectrum slot between 4G and 5G. And it's typically used on lower frequency bands like band 3 here in Europe, 1800 megahertz. And what we're seeing is upload performance is very similar to what we're already seeing on 4G with the last couple of years. So basically what enables is faster download speeds without the need for a huge amount of new equipment like antennas and a huge investment in the backhaul. So we spoke about non-standalone and standalone. 5G non-standalone allows the bandwidth to be significantly increased by using new radios, wider bandwidths, new frequency bands. What we're seeing already is band 78, which is C-band 3.5 to 3.8 gigahertz. And most spectrum slots are either 80 megahertz wide or 100 megahertz wide in the spectrum auctions. 5G non-standalone means that the core network is still the 4G evolved packet core. And so basically what we're seeing is faster speeds, slightly reduced latency, and then the other part, which is another new frequency bands, is millimeter waves. So which above 6 gigahertz, typically what we've seen is figures like 26 gigahertz and even higher to crazy gigahertz numbers like 78 gigahertz, etc. So 5G standalone then, what is this? This is a ground up rebuild of the mobile network. It will use the same radio equipment and the frequency bands as we've seen on non-standalone, but is a completely new core network. Most vendors are offering this as a virtualized or cloud native, so IT apps running on common hardware. And we've seen some papers suggesting that some networks will run their core networks on something like AWS. So in the end of the day, what it will give is higher throughput again and lower latency, as it's a 5G stack from end to end. And the last point, which is going to be specifically interesting to us in the broadcast world, is network slicing. So network slicing is a way of partitioning the 5G pipe in a vertical form from all the way from the RF carrier. So allocating a portion of the RF spectrum to a user, SIM card or modem, and it creates a pipe through the entire network from the radio all the way to your endpoint, which may be in the cloud, in the internet, anywhere, or back to your facility. And what we've been told is that this will typically be an IPsec VPN. So on this logical network built across the 5G infrastructure that the network has built, they will apply a QoS profile, giving you a guaranteed bandwidth, latency, and packet loss figure, similar to what we see on leased lines nowadays on Ethernet pipes or E-lines. You're not competing with the general public, so your average Joe doing a big upload or download should not impact your connection, and so that we should not see any crazy fluctuations in any of the above points. So this has many applications, including broadcast. So things like robotics, remote medical procedures, all this sort of thing, like remote monitoring of autonomous vehicles, etc., is all included in applications on 5G slicing. What we don't know yet, because 5G cores have not been built, we don't have any of the commercial aspects yet on slicing, and we don't have definite date of when a service will be offered to the likes of us or any other operators in Ireland looking to use the service. So where we started with 5G, in December last year, when we first had access to a 5G network, our first 5G SIM and modem, we did some testing. It wasn't actually a test. We wanted to get a clean feed from Croke Park in Dublin back to our HQ to get it back here faster than we could get a drive brought back down by road, as we were cutting highlights of this game for the next morning. So what we did was we bonded it in with the 4G networks that we would have normally done. We sent a 20 megabit transport stream back here to our HQ, and you see in the screenshots there, not a huge amount of dropped packets, but it was significant enough. And you can see the screenshot here of the tweet I wrote on December 13th last year, just on our first foray into 5G. And what we'll see later on is that this actually performed worse in terms of packet loss than using a single 5G connection. So that was quite interesting. So here is our current setup for what we're doing in terms of 5G. We're using this every week on live OTT sports broadcast. So we're doing live games straight to the web to a pay-per-view OTT platform. What we're using is ordinary 5G SIM. So no QoS or slicing, that's not available yet. We're using one of Kieran's encoders. So OB encoder, we're playing it safe at 15 megabits per second of a transport stream. And we're using the ZXI protocol to feed into AWS Media Connect. Zixi is what we were using for bonding before, so it made sense just to carry on with that, and it gives us loads of statistics. We're using a single modem from QuickTel and 4 antennas, so no directional antennas yet. We're just trying to give it the worst case scenario almost at the moment, and we're utilizing 4x4 MIMO. So that then goes through our AWS workflow where we do graphics, replays, and transcoding and push to OTT. And our receiver at base then is another Open Broadcast Systems decoder. I look at some of the locations that we've been using. In Waterford City, there are 2 venues that we cover. Location A here, you'll see, is about 1 kilometer away from the tower, and we actually do not have line of sight. So initially we thought it wouldn't work that well, as there is a hill between the, as you can see, location A there and the 5G tower on the map. So we thought it wouldn't perform well, but it in fact performed quite well. Location B then is directly adjacent to where the 5G tower is. We've got line of sight. It's about 300 meters away. Excellent performance there, best that we could expect there. And then our third location, again, a non-line of sight location in Dublin. And we saw some interesting ping times there, and I'll show in a later slide. And as you can see there is a comparison between the networks, 3 of the primary networks here in Ireland. So we have a 4G network from network A and the 5G network that we were using, and you can see that there is a huge leap in speed in both the upload and download speeds. And then the other 2 4G networks are typically what you would see on 4G or 4G plus. We also had a VDSL fiber to the cabinet line, and as you can see, the upload performance on that lags seriously behind the mobile networks, but you're pretty stable in terms of that bandwidth. But what's interesting is that the 5G network completely blows everything away, including the wired connection in terms of bandwidth and speed, and the latency is also comparable. So here's a quick picture of the serving tower in locations A and B. The equipment uses Huawei's integrated 5G radio antenna. I've seen these, and it's basically a power cable and a fiber going into the unit. Everything is done inside, and it is the 32 by 32 massive MIMO unit. And I think this helps in the aspect of beam forming and getting through non-line of sight locations, so you can really target the beam onto where the user is located. So here are some of the screenshots of the results that we've had in these tests. Using our 15 megabit transport stream and the equipment listed before, in a lot of cases, we're not seeing any packet loss or ARQ recoveries at all over the course of 2 to 3 hours. As you can see, we're in these screenshots, there's 2 hours 42 minutes with only 18 packet recoveries, and also the lower screenshot was running for just over an hour and there were 0 packet drops. Our average round trip time we're seeing is in around 15 milliseconds, and the lowest observed round trip time was 9 milliseconds, which is quite astonishing for a mobile connection. The jitter does vary a lot, and this, I think, is related to how the radio operates in the 5G domain. We've seen some occasional huge bursts to 250 milliseconds, and at a completely uneducated guess is due to the use of time division duplexing on this particular band. So if someone else tries to download on your cell, it basically has to pause your upload transmission for a short time. So here's a nice little map of location C, which is Croke Park in Dublin, the headquarters of the GAA. And you can see about 3 miles away is AWS EU West 1 data center. So this is where we saw the lowest ping time of 9 milliseconds. And I believe I saw 7 at some stage, but I haven't got anything to back that up at the moment. But hopefully we will see that and less again in the future. So what we want to do from now on is start pushing the bit rate and reducing our buffer time, our buffer windows. And the magic number is in around 30 megabits per second and a 250 millisecond buffer. So that would put us in the same realm as satellite, as most of our satellite transmissions run at approximately 30 megabits per second. And your delay through the air on satellite is about 250 milliseconds also as it travels the distance through space. And then also the hot topic at the moment is remote production. So we want to push multiple camera angles back to our base and cut them here and see if we can enjoy the benefits of that. Push up the bandwidth needed for these multiple camera angles, possibly using bonding over multiple networks. And so that's next on the agenda.
So to go back to the viewpoint again from an encoder manufacturer's point of view, 5G remote production is going to be the hot topic. As we've seen, 5G can deliver an order of magnitude 5 to 10 milliseconds in some cases. That's only going to improve, especially with things like AWS wavelength, where you can do processing closer to the 5G core. And again, with traditional fixed form factor encoders, it's definitely achievable to do something like 100 milliseconds end to end with enough FEC and some ARQ. That's definitely achievable at modest bit rates with something like H.264. So I think that's probably doable today, apart from these big, large network ping spikes. And I would emphasize we've seen that both in the UK and in Ireland. It's not something specific to one network. We've seen this over here in London on both networks here, and I think Fiachna has probably seen it on the multiple 5G network providers in Ireland. So that's really the limiting factor, I suspect. Probably are ways you could hack around it with some form of 2022-7, so hoping that both networks don't have the ping spike at the same time. But again, that's more working around the problem than actually fixing the problem itself. Next slide. There are other use cases for 5G that we haven't really talked about that aren't quite broadcast related, but are related sort of. In-car cameras is a great example for racing. These often use very high-end RF equipment, such that only the most expensive high-end racing leagues races can afford it. This example is semi-professional racing at quite famous tracks such as Le Mans, Spa, and Magny-Cours. So these are semi-professional drivers that use more for training and also just some also for fun, so a mixture. And they use in-car video both for the broadcast, but more importantly, from a team's point of view, as part of the race. But they have a slightly different use case to broadcast in that they care more about latency than picture stability. So they're happy, for example, if the car goes under a bridge or in a tunnel or part of the track with no signal, for it to glitch and then immediately come back. You've probably seen that on things like Formula One. From time to time, there's a glitch, but it's not a big deal as long as you can follow the action quickly, as long as you come back. What you can see as well from the picture is we're rendering a multi-view in the car. So you get the driver, the front of the car, and the rear of the car. And this is very fast-moving action as well. So it's actually very challenging for encoders. And in particular, some of the backpack-style encoders, they're using sort of mobile phone chipsets. And they're really struggling with both the fast movement of the track and the fact there are actually 3 different images there. So your prediction is going to go all over the place. They also are a bit challenged with adaptive bitrate, for example, because what happens is the car goes under a bridge or in a tunnel or through a bit of the arena, a bit of the track with no signal. They adapt all the way down such that you basically get blocks on the screen. And then the algorithm spends ages figuring out that it can go and ramp the bitrate up. So, and the problem is, again, you get unstable picture quality throughout the race, which isn't particularly useful for the team if they can't really see what's going on. And so currently we're doing this with the bottom setup. It's actually an encoder based around an Intel NUC in the car. And we're using bonded 4G. So this gives us broadly 3 to 5 seconds latency. And this lets the team do non-interactive kind of strategic decisions, pitting, this sort of thing. But with 5G, we could cut this to 100 milliseconds, 200 milliseconds. So something comparable to the high-end RF solutions used. And this means the team can actually go and make interactive instant decisions. The data, the live video from the car is essentially real time as opposed to being delayed. So this is another use case where 5G can be very useful for both broadcast and non-broadcast use cases. And I think that's the last slide. So I'd like to hand it over to Brad for Q&A.
All right, great. Thank you, Kieran. I don't see any questions in the chat right now. I did have a question though for you, and I was just curious if you were looking at always having a bonded configuration. Do you think that this is going to be something that's purely 5G, or do you see 5G, 4G, and whatever else you happen to have available all kind of being bonded together into the connectivity that you use at these sort of venues?
So from my point of view, you wouldn't, if as soon as you start incorporating 4G in, that's you're back to the worst case latency. So doing true remote production is going to be challenging at half a second to a second. It's doable, but harder. So that's an argument against 4G. Certainly, I think Fiachna could maybe answer, but bonded 5G would give you the resilience and in principle give you the latency that you needed to do remote production. Fiachna, do you have any comments? Because you talked a bit about bonding 4G and 5G.
Yeah, so I guess go back to, go back a few slides to this one where we bonded 4G and 5G, and it actually performed worse in terms of jitter, round trip time, and packet drops. So I think bonding 4G with 5G, I'm not quite sure, because the 4G might have some drawbacks that will only make it slightly better than 4G, but definitely bonding multiple 5G connections, I think that would be a good idea.
Yeah, it makes sense. I guess it would depend on the application and whether, if it's news and you just want to be sure you've got something and you can accept things bouncing around, that's one thing. If you're doing sport or some other application, then you wouldn't want that. So it would be to some extent maybe application dependent. We do have a question from Erling.
Thanks for the presentation. Quick question for me is, do you think some of this performance that you're seeing now could be due to the fact that not so many people are using the 5G network, and as more people start using 5G, and in particular people who just pop a 5G modem at home and use it instead of their broadband, you really start seeing some more deterioration of this performance?
I'll answer yes. That's the elephant in the room at the moment. But that said, there are more frequency bands being allocated to 5G, more and more slicing notwithstanding, bonding, and the speeds are still, at the moment, there isn't quite a consumer use case that can really suck up 100 megabits of upload just yet. So that's probably the current state of play. But there's more and more smaller cell towers as well. So the cell tower next to my home is literally 10 meters away. If you get increased density of cell towers, this is less likely to be an issue. Anything else, Fiachna?
I guess you can look at it as well, like from the migration from 3G to 4G, your bandwidth pipe became bigger. So moving from 4G to 5G, the cake is bigger. If you have the same amount of slices, you're going to have a bigger slice yourself, which will help moving this direction. When we start pushing towards, the 100+ megabits for remote production, slicing is going to become quite important there. And, in theory, slicing does away with that problem completely, as you will have some sort of guarantee on your bandwidth.
One quick question, and then we do need to move on, but it's been a topic before that perhaps when you're covering the most important events, that life safety services may simply take all the bandwidth and that's it. And so you would be in the middle of a national broadcast covering something that was really important, and that basically that bandwidth could go away. I'm sure there's been discussion in the industry about that. I haven't really been aware of it recently. Is there any recognition of that as an issue and discussion about what to do about it, or is that just one of those things that's a reality of where we are at the moment?
To be fair, that's been a reality for the last 30 years. Telephone lines are being used in broadcasting for all sorts of other applications, back behind the camera and in front of the camera. And if someone calls 911, the network could, in principle, rightly so, obviously kick you out. I'm not sure there's been any further discussion about data priority. I'm not sure safety of life services have priority yet. It might be that the government or government customers. So slicing, almost certainly, in my opinion, government customers will be first. They're huge, voracious data users. They have, ambulances, fire trucks that need vast amounts of data. And when slicing comes, it won't be broadcasters that will get it first. It will be government users. So in that respect, they may be a sort of slicing war going on in some respects, but whereas they get priority, and probably rightly so. But you could argue that's the same in various other industries. And if the military wants to use bits of RF spectrum GPS is a classic example of this, for PTP and other things. If the military wants to jam GPS, which has happened at certain large venues, for example, if President Biden rocks up or Vladimir Putin rocks up, you will not have GPS service. End of story.
Right.
So that is a comparable issue that we kind of already face today, and I believe has affected actual broadcasts so some of the 2110 trucks have had to drop back to black and burst because dignitaries have come in and GPS service has been lost. So it's already an issue, to be honest. I don't think 5G makes that a new issue.
Yeah, exactly. And I think it just is a case where smart broadcasters will work with their vendors to be sure that they've got options available. So, all right, with that, I thank you guys very much. Excellent presentation. We always appreciate real world experiences with new technologies like this. So thanks to both of you.